finding overarching solutions may be good for everybody. That's things, like regarding CI, software security, training, etc. HBSF will also likely help with organizing some of these trainings, as well as like user group meetings and things like that. And likely pay for some of the community infrastructure, such as, web page, maybe some of the CI, maybe the Slack support. We are working on that right now. If you want to get involved, you can talk to us. There's a number of us from the Kokkos side who are heavily involved. Christian, Damien, and Julian. We are all active in HBSF. We are still in the bring-up phase, so the working groups, for example, are not yet fully constituted. The technical advisory committee, etc., is just working on getting that started. But I'll hope by November, when supercomputing comes around, we have a lot of that, at least nominally started. Another thing we've been trying to improve is a bit of our release mechanism. One thing which changed, which I warned last time about and which already changed now, is that develop is the default branch of Kokkos Core and Kokkos kernels. We switched that last release. Master branch is deprecated. We still updated it to 4.4 right now, but at some point this branch will go away. So if you have scripts which pull from master, try and update them. And yeah. The other thing we did is, that goes toward that security theme I mentioned earlier, where HBSF also matters, is that we started to publish signed release artifacts. So again, you can go to a release page. That's where you find everything. Source distributions is the source archives we uploaded as the Kokkos team. And when the summary files are related to those are then hashes as well as keys to verify the integrity of the hash. So that means you can download the source archives where you can check with the hashes that the hash maps, the hash is correct. And then you can use the encryption key to verify that the hash is actually the right hash, right? That it's signed. Assets are all the files above, and there is one thing to notice in the assets. There is the auto-generated source code zip and tar.gz in there. These are GitHub generated, and they don't actually promise a stable checksum. So if you download those guys, which was previously only the tar files and whatnot we had there, those things get potentially generated when you actually try to download them by some magic in the GitHub site. So these are not stable. And it won't go through this. This is essentially the commands to, kind of check, download these things and check them, right? You download the actual tar file, you download the SHA, you download the, signature for that thing and a key to verify it, and do all these things, and you can essentially check that this stuff is hopefully not tampered with. One other thing, Kokkos 5 is going to come next summer. There's probably going to be more, there's going to be more releases before that, but Kokkos 5 is coming next summer, and we will require C++20. You can start preparing for that now, right? Check availability of compilers on your systems, test with C++20 enabled, maybe start just with a CPU build, but you can also do GPU builds. The minimum compiler requirements for C++20 will definitely be different than they are right now for C++17. And you will hear later a little bit about that in the build system section. There is nothing wrong for your project to require C++20 now, if you feel already ready, right? And all the compilers are available you need. And so if you want to do that, you can start now. MD-span interoperability. So this was a thing, we've been working a long time on MD-span, which is a non-owning multidimensional view of data. It's kind of like, it's based on Vue, right? The design we put into the standard, but it does not own or reference count, generally. And in particular, it doesn't have any constructors which would actually allocate memory. It's part of a C++23 standard, and it's also a major component in some of the new features coming out, things like std.linalg, which is C++26. What MDSpan can do for you is it can improve interoperability between different codes, right? Because it is a standardized interface. Think of it essentially as a standardized, unmanaged Kokkos view. What we did in this release is we added conversion functions to and from MDSpan. So for the view, right? So you can construct a view from an MDSpan. You can convert a view into an MDSpan, and there's an explicit toMDSpan function you can use. The conversion rules for this follow essentially the same principles you have between views, of different types, as well as MDSpans of different types, right? Like you can convert from a non-const element type to a const element type, but not vice versa, right? You can't convert between ranks as different types of ranks, right? But you can between static extents and dynamic extents, etc. So all of that is essentially the same. One important concept here is the natural MDSpan. So that's essentially the type of MDSpan which is the direct expression of what the view type is, right? So you get, the value type is going to be the same value type, right? The index type in this case is going to be size t. The extents type is based on, the static and dynamic extents of the view, and the layout type then is, layout left padded. When if you had Kokkos layout left, layout right padded. If you had Kokkos layout right, and layout straight if you had Kokkos layout straight. So there's essentially two primary use cases for this, where this could be, in particular, in the long run, beneficial to you. One is for interfaces with non-Kokkos code, right? If you expect, for example, your code to be called from, non-Kokkos code, then your library, then using MDSpan at the interface gives you essentially a standardized interface. It also gives you a fully standardized replacement for unmanaged view, right? If you use unmanaged views extensively, then thinking about whether to use MDSpan there is potentially a thing to do. You can find the full specification here at that link. One thing I should say, we didn't say here, we have, you find MDSpan in the Kokkos namespace. We cannot use the standard library provided one, like LLVM has one we contributed for GPU builds because, it doesn't have device markup. So in that case, we still have to use our own version of it. And we have to use our own version if we are below C++23, right? Because MDSpan is only C++23. Our version works right now in C++17, right? So you can use that already as Kokkos MDSpan. Eventually, in cases where we can use the standard provided MDSpan, Kokkos MDSpan will just be an alias for that. Okay, with that, let's go to backend updates.
All right, next slide. All right, so we start off with CUDA. We noticed that we had some compile time issues when we enabled debug bound check, mostly related to inlining of Kokkos support. So we fixed that. It should be much faster to enable that with NVCC now. Whereas, basically getting to standards we had from compiling with Clang. We added another flag for NVCC wrapper to have it more compatible with NVCC. With a shortened version for disable warnings, -W was already supported. And then finally, for team policies, we are now using team size recommended internally when you don't provide anything. So this is in line with how all other backends are doing that. So basically, team size, you can rely on team size recommended returning what you would get by default there. Next slide. For HIP, we had already introduced Impl HIP unified memory support in the 4.3.1 release for MI300, which basically means that the HIP space acts as a unified memory space so that you can access it both on the host and device. A similar update for CUDA is coming later. Then we also added some flags for architecture flags for HIP, so you can control that some better. There was a user request for it to have more fine-grained control. You need to do that currently in the impl namespace since it's considered a very advanced option, and then you need to set all the architectures yourself. Finally, for the HIP backend, we reworked the atomics to use built-ins, which should also give you some improvements. Next slide. On the SQL backend, the biggest update is that we are now supporting Kokkos graphs, which we already had for the host backends, CUDA and HIP. And there will probably be more updates coming up for the next release. Then in the last release, in the 4.3.0, we already had support for CUDA multi-GPU, and SQL should have worked out of the box pretty much, but we made sure in this release that it actually works. We need to fix a couple of things, but that should be good now. HIP support should be coming in the next release or so. And then we had some performance improvements for the top level per reduce, per scan, and team reduce, basically giving the compiler some more information so that the shuffles are working better. And the last update here is for thread safety, which will come up a couple times more here, so that team policy pair reduce is actually enqueued properly. Next slide. Now for the remaining backends, OpenACC now use the correct async queue. This change is also related to the thread safety updates. And then we have OpenMP target parallel scan data race update, again related to the thread safety things. We have another update for OpenMP target now that we are using the correct loop ordering in the MD range policy, where previously we were not honoring this. And for the HPX backend, we noticed that there was some compilation issues with NVCC, which is fixed now. Also updating HPX minimum versions. Okay, with that, we come to general enhancement. The Kokkos array has gotten more updates over the last releases. In this release, we added 2 array. So basically, you can now construct an array with 2 array from a C-style array, like you see in the first example, from an initializer list without specifying the template argument or specifying the template argument converting from an int, say, in the third example. Furthermore, we implemented Kokkos swap now between arrays of the same size and type, so that can be used. And finally, we made array equality comparable, again, for the same size and number of elements, as you see in the last example. Next slide. Yeah. Okay. Then for the team policy, we added some more CTED, like we did in the previous releases for range policy and MD range policy. So if you just provide a default constructor, then you get a default constructor team policy. Same if you provide just extends like a range and then for default execution space, and only if you pass in something other than the default execution space, the actual execution space is deduced, as you can see in the last example. Next slide. Next, we updated our complex implementation according to some changes in the standard. Basically, C++26 allows using the tuple protocol, so you can access the individual components now with the common syntax that you already had for tuples, as you can see here in the second line, and then you can assert that this is all correct after calling Kokkos swap on it. Next slide. And then we had a problem we noticed with our iterators that are used commonly in the algorithms classes. Basically, we already had that you could assign from a non-const to a const view type before. And that didn't work for the algorithms iterators, and we made sure that that works now. So of course you can assign from a constant iterator to constant iterator, but now also from a non-const to const, but of course not from a const to a non-const, just like C++ syntax. Next slide. And then we have another update for the algorithms. Basically, where we noticed that adjacent differences allowed overlapping iterators, resulting in wrong results, which is disallowed by the standard. And now we tried to detect that in some cases, at least if we have the same stride. Then we try to see if these are overlapping or not. You can see that in the second example here. So we have a view double two, like with static extend 2, and then a dynamic extend. And we take a subview with respect to the first dimension, so that the view access are interleaved for the subviews we create from them, and the begin operators. So this is the allowed, since we know that the memory we access won't overlap. But if they were to overlap, then we would detect that, but only if the stride is the same for the views we pass in. Next slide. For SIMD, we previously only supported the full vector width, and now we allow to have like smaller types where we can basically use smaller types of them. So we see that here for AVX 512, we can both we have both the native type, we have the SIMD type, which is just using the smaller type here with AVX 512 fixed as 8. And then we can also use like more elements of that, basically 16, giving us a little bit more freedom, basically. And we do that for AVX 512, and Neon, which is kind of like all the SIMD architectures that we support right now. Finally, some users informed us that the reference counting in views for host backends is sometimes very slow. We discovered that we can mitigate that by applying the unlikely attribute in the reference counting, and we saw the biggest impact here in LLVM compilers. Luckily, this didn't have any impact on device views, but this might help you if you are using a lot of reference counting with host views. Next slide. With that, we come to the build system updates. As Christian mentioned before, we will require C++20 in the next year. What that means in terms of minimum compiler versions, you see here. We go from Clang support, which is currently like version 10, to 14, which is then also in line with what we need for Clang plus CUDA. Clang and OpenMP target kind of stays the same because we already have a pretty high requirement there. For GCC, we picked 10.1, which is high enough that we can fully support concepts. The Intel compiler itself is not supported anymore, which probably many of us will be happy about. And then Intel LLVM, the CPU, is bumped a little bit to 2022. For SYCL, the support remains the same. NVCC, we go from 11 to 12. For HIPCC, there are no changes. 5.2.0 works fine. NVHPC is also no changes. And then for MSVC, we also bump it a little bit up so that we can fully use concepts. Next slide.
Yeah. One second. Why does this not work? No.
All right. Okay, the second part of the build system updates is here. We worked a little bit more on the NVIDIA Grace and Grace Hopper architectures. In particular, for the host architecture, we added some flags that you can use, like you can specify that you want to use Neoverse v2 explicitly. Then we fixed some Intel GPU architectures. Basically, that you can use the same options in the makefile and the CMake file, which was previously there was a slight mismatch, but that should be easier now. For the threads backend, we had incorrect path in the makefile.kokkos, which probably didn't even work before this release. It was a bug fix kind of. And then with newer CMake versions and newer CUDA versions, we discovered some incompatibilities since we were bundling CUDA to find CUDA toolkit.cmake. And so now we just basically, we just use the CUDA toolkit again. So that was kind of a problem, but it should be fixed. The next 2 points are related to using Kokkos as compile language. So if you don't want to use for Kokkos to use C++ as language, but rather CUDA, and then specify CUDA or HIP as your language downstream, you can do that. But we realized that this had some issues with OpenMP since we were enabling CXX for both of them, like other languages for all the languages. So that should be fixed now. The last point here is NVHPC as CUDA device compiler. That was always a little bit iffy, and we in the end just decided to remove it. So whenever you use NVHPC, that will only be used as host compiler. In the previous release, we had that we needed an impl option to make that a device compiler.
Let me add 2 things to that. The one thing, the OpenMP, we effectively enabled it for everything, which means that you got it potentially enabled for Fortran downstream. So we don't do that anymore. And for the NVHPC, this was an experimental thing NVIDIA did, but that is not supported anymore. So by NVIDIA, so we removed that as well. Okay.
All right.
Damien? Damien, if you're talking, we can't hear you.
Oh, that's too bad. Okay, let me start again. So yeah, breaking changes. So we internally had some specialization of Kokkos View for arrays that we got rid of. Essentially, the Kokkos array was treated as an extra, the dimension was treated as an extra compile time dimension in the view. Unless you were doing views of arrays and you were directly using the underlying pointer and reinterpreting the view, that shouldn't be an issue. We could not find anywhere downstream in any of the application we work with and in Trilinos and whatnot any use, but we're just telling you that if you were doing such things, that you might have surprises. And so one of the good thing is we had people try to construct and manage view of arrays, and they can do it now. So we got rid of a lot of complexity, and so we don't really anticipate it breaking your code, but we acknowledge we did that. The other one, it was some experimental exception type that we had. that unless you directly named and used, you should not be able to observe it. So we couldn't find anyone using it, and internally we were we were throwing them, but we were catching them, and underneath the hood we were just throwing regular stud runtime exception. So you should not be affected by that unless you explicitly name that in your code. So then you're gonna see in the bug fixes, but we did some changes for thread safety that can lead to deadlocks in user code that violates Kokkos semantics. So code that is invalid but happened to work in the past. But we will drill on it later. Okay, next. So deprecations. So we deprecated the, so for deep copy overload that take unordered maps, we deprecated the deep copy if an allocation would be necessary. So now they need to have the same capacity to deep copy. So if you're not familiar with how we handle deprecation, by default, I think we still enable deprecated code 4 in the current release, but we encourage you to disable it and to be aware. And so if you disable it, you won't have any of the code. Otherwise, you should be getting warnings already if you were relying on this facility. Then we had a little mishap in the previous releases. We accidentally enabled some construction of range policy where an implicit conversion would happen from chunk side. So it's extremely unlikely you hit by that, but we made it so we made it explicit to chunk size. So it's extremely unlikely that it hits you. It has just happened to work over the last release. And then, so it was a funny one that's kind of related to the previous one. We had a number of execution spaces that could implicitly be constructed from other parameters. So all these constructors were like interoperability constructor, things like the CUDA execution space or heap execution space that take a stream. I think there were a few backends that could construct one integer that specify either some kind of async queue marker or some number of threads. And so this happened to work in the past, but we made them explicit. So you're going to get warnings if you are using this, but yeah, just if you update your code will be compatible with older Kokkos and newer Kokkos. I think that's all.
Yeah. So where that could have been happening is, right, if you, for example, created a range policy, you potentially could have created a range policy from a CUDA stream, which was definitely not intended, right, through the implicit construction of an execution space argument.
Yep.
So stuff like that, right? That is something we deprecated and or should not work or was never supposed to work, but accidentally did.
Yep. Next one. Okay, so this one, yeah, hopefully no one really noticed, but Kokkos array, so you saw we were doing a lot of work to try to align it further with stud array. And so here in comment, you had the real horrible signature of the old Kokkos array where there was some hidden training template parameter. And so we are deprecating it. So we're going to get rid of it. We understand that maybe someone has old code that may depend on it, so we buy you more time. But essentially, Kokkos array is going to be much more aligned with stud array. So we deprecate the ability for non-owning arrays for dynamically sized contiguous and threaded functionality, which was only used in the view specialization that we got rid of. And anyway, so we don't anticipate that it's going to break your code, but this anyway, you would get, if you were relying on it now, you should be getting deprecation warnings. Next slide. And so we got rid of some layered tile class template that was actually never really usable and never really working. We couldn't find any use, but we just to be safe, we deprecated it, and we also deprecated some traits that we had that could tell you whether it was this experimental type. Yeah, nothing else to say. Next. Oh, and that one is another fun one. So Kokkos pair could optionally only have one element, which you would make by specifying a void as a training template parameter. And we decided that we didn't really want to support that anymore, and we couldn't really find much use for that. But anyway, this is something we got rid of. That's not supported by the standards. It was never documented. We weren't really properly testing it, and so we are deprecating it. Next. All right, bug fixes. So this one, we had had in the past few years some very weird bug reports that were always around people who were doing weird things with shared libraries. And essentially they were, I mean, some were amazing. Some were like launching a parallel for range policy and getting an error that there is not enough shared memory, which we don't use shared memory for that. But anyway, all these things were related to some inline static member variables we had in some of the backends, which did not play very well either with users adding downstream visibility flags to their library, and didn't play very well with Python wrapper, and also with when you were dynamically loading and setting up the RTLD DeepMind option. So anyway, we initially our reaction was always to say, well, don't do weird thing, but we decided to add some builds that actually check that even if you messed with this, you're going to get the correct behavior. Essentially, these things were around symbols that are supposed to be unique in Kokkos execution environments that ended up being duplicated and giving you absolutely nuts behavior downstream. That's very hard to debug. Okay, next. Okay, so then, so we did a number of fixes related to thread safety. And so over the last few releases, we did a number of incremental improvements that let you, like for instance, use the serial backend from different threads. And so it's allowed to dispatch work from different threads to the same execution space instance. And we were usually pretty diligent at making sure that if there were shared space, like things like reduction, that we wouldn't give you absolute garbage answer by not protecting this private allocation. But semantically, if you submit work to the same instances, we should be executing things in order. And so this, all these things we did at least guarantee that they do not run concurrently. We don't have like full in order guarantee yet. But it made us add a number of locks that were not present in the serial and OpenMP backend. And this is the thing that triggered some basically that flagged some invalid use of views, and that could have made that your code started hanging, but we're going to drill more in a few slides. So next. I'm going to skip this one because I expect it's just showing you that, yeah, I don't care. Let's move. I don't think it's very interesting. So this one, yeah, so other fixes, the experimental algorithm for each, we changed the return type to match stood for each. So we added support. So for a while now, we support view with non-default constructible values, but it didn't used to work in realloc. And so now we fixed it, and you can do that. So you can do a realloc and pass a view alloc property that says without initializing, and you'd be able to use it. So we fixed some undefined behavior in the view initialization and or view field with zeros. Essentially, we were doing some naughty things that a more modern compiler caught us with. So we do some optimization when we know that something is going to be filled only with zeros. Where we instead of doing launching a kernel, we sometimes will do something like zero memset. And the logic that we had to identify that it's okay to do that was something we should not have been doing. We don't anticipate that it has impact on real code, but one newer compiler starting yelling at us. Actually, no, it was more than that. I think we started having some sec fault. But anyway, we don't really anticipate that. I mean, it's the code is just more correct than before. It's not, major impact on you. So yeah, update is a good idea for this. So sort by key, we fix the compilation. If you were using sort by key on a host execution space with CUDA enabled, so yeah, it wasn't possible before, and it is. So if you haven't noticed it, don't worry about it. And we fixed the reference counting. Okay, so that one is something that was theoretically possible, and I don't know any report of this haven't ever happened. But essentially, if you passed us a functor, which when we were copying it to dispatch work was throwing an exception, it was theoretically, and you caught it and kept going, it was theoretically possible to disable reference counting in Kokkos, which means then when we are copying views, and basically a lot of things would function poorly after that. And so even though I don't know of any reports of this ever happening, this was theoretically possible. And the last one was an interesting one. So you can initialize Kokkos either with argc argv, or you can choose to initialize with initialization settings. And we had done a mistake. If you were initializing with initialization settings, we were not looking at the print configuration setting. We were only getting the environment one. So small bug, but fixed now. Okay, so now I want to spend a bit more time discussing views in general, and showing discuss how some of the bug fixes that we did related to thread safety might impact your code. Okay, so let's go. So let's start first with just a little reminder of how views work. So here let's take some view T star on the host space. So V with n elements known at runtime. So you create your view and you do stuff with it, and then when the curly brace closes, this thing is going to be, assuming that we didn't keep a reference to it anywhere, it's going to be destructed. So it's going to call the destructor of view. Next. And so what happened when we do that? So it's equivalent to us launching first a parallel for, where we will, on the host execution space, on the default host execution space, where we will explicitly call the destructor for every single element. So we do some cleanup, and then we deallocate memory. So we call Kokkos 3 on this data. So that's more or less equivalent to that, what we do internally when a view go out of scope. Next. So now, what if T is a view or some user-defined type that you might have in your code that has a view data member? Okay. So and so to be clear, this is the same, right? Whether you do a view or a view of some type that contains a view. So so we have a full section in our programming guide about views that have been there longer than I've been in the team. Like, I don't know, since forever this section has been there. And this thing really is clear and tells you, don't do that. But if you do, you should do it this way. That's the right way of doing it. So you have some type, so that I got naughty. That here is a view that can be in some other memory space. It doesn't have to be the host memory space, or it could be your struct that has a view inside. So when you construct it, so you construct the outer view. So you arbitrarily here I decided to rank 2 view. So with 2 runtime dimensions. So V, I'm constructing it, and I use the without initializing property. And so here it's a 2x3 matrix. And so then in your code, on the host, you have to create initialize elements yourself using a placement new. And this is the syntax I've written here. So you do new, you take the address of an element, and you call the constructor. And so here I took 3 elements in this 2x3 matrix, and I'm constructing this new element. And so then you use your view of views wherever you see fit. And then at the end, you are responsible for cleaning up, which means for all of these placement news that you did, you need yourself to call the destructor. So that's all these 3 calls that you're supposed to do it yourself. So it must be done on the host and not within a parallel region. Okay, next.
To make that clear, right? Without initializing essentially implies also without destruction,
yeah.
Right? That's why you have to destruct yourself.
Yeah, and so in this example, arbitrarily, I decided to, you can initialize them, all of them, or just the one you need. But yeah, for every single that you constructed, you are responsible for calling the destructor. Kokkos cannot know it and cannot do it for you. So then, so we're telling you, you were supposed to clean up. And so you might be wondering, okay, what happened if I didn't? Okay, so what happened? So, well, it depends. It depends. If you pass the without initializing allocation property, just like we tell you in our programming guide, what happened is you potentially leak resources. So unless, if you had the code I had written in the previous slides, and you don't, somehow escape references to the inner elements, yeah, you definitely leak resources. Those things are never freed. You just have, leaks in your code. Otherwise, yeah, if there was another reference, the last view reference to it, when it gets out of scope, we'll do the cleanup. Okay, otherwise, if you just construct it, you ignore entirely what we said, and you did a regular view construction, your program is now potentially hanging. If you're using so if the outer view in the example always was on host space, but if the inner view is also on host, like your code is definitely hanging now. To be fair, so the changes we did were in the serial and host and OpenMP backend. If you were using the Threads backend, your code on previous version of Kokkos would already have hung. You would already have run into problems, but you may never use this backend and not have noticed that your code was semantically wrong. If you use device backend such as CUDA or HIP or the inner views, well, your code is still gonna kind of work, but it's still semantically incorrect, your code. So what happened? So what happened on the when the inner views were on the host is that the outer view destructor. So when the outer view was getting out of scope, it launches a parallel regions to end the lifetime of all individual elements. So Kokkos is going to do the cleanup, and then if any of the individual elements has inside some non-empty inner view that goes out of scope, then we will attempt to nest yet another launching, of a kernel to destruct and to deallocate, except that it's semantically incorrect to nest this thing. And if you're using, if your inner view was on host, Kokkos will internally attempt to acquire a lock that's already engaged, and that's why your code is just gonna run for a very long time. And one second question. And so, oh yeah, okay, no, sorry, I already said that. Okay, and so here it's more looking ahead. Because we discovered like shortly before the release that misuse of Kokkos View was quite widespread. If you have a major problem in your application because things don't work anymore, there is ways already in Kokkos 4.4 to mitigate that, but talk to us. But going forwards, we actually last week, I mean, we've been working on thinking about that for a bit longer. But anyway, we're going to introduce some new view allocation property, which at the moment is tentatively called sequential host init, which would let you. So if you look at the code here, when you create it, if you specify this, so you tell Kokkos, please initialize all elements on the host sequentially, and please do the same sequential on the host when you delete. And so then when you want to set potentially to other value your elements, you can do directly assignments, and Kokkos will handle properly the element destruction. The thing we implemented in 4.5 at the moment does not support non-default constructible element types. So if you need it really badly, you should talk to us sooner than later. We are looking for feedback. We had a few people, a couple of persons say that they would like this to be included in the next patch release because they need it. So we are gauging appetite right now. So if you really need this really badly, you should probably tell us. Okay, next. So this is the end actually. So I guess we could open the floor for question, but here is just reminding you how you can contribute.
First, we probably should give our Kokkos kernels friends some time, right?
You want to do feed? Yeah, sure. So let's go to Kokkos kernel. Hold your question till the end.
Luke, you gonna share?
Yeah. Go to full screen, I guess. Does that look reasonable?
Yep.
Okay. So for this release, the highlights are going to be block sparse triangular solve, some improvement in our reverse Cuthill key, some changes to TPLs, especially for SPMV and SPGEM, and some batched blended solvers that were added. And then actually, I do not think I have other minor changes listed. The usual slide for where to find us. Okay, so block SPTRSV. So we have the support for block sparse matrices, so block CRS in Kokkos kernels for the sparse triangular solve. In the previous release, we had introduced this block sparse ILU. So with these two pieces, you can now actually use ILU and perform the solves after your factorization, which makes sense. The only change you have to make is provide a block size to the interface in the API. And then, so yes, not all the SPTRSV algorithms are going to support this block format. So sparse chain and supernodal algorithms are not supported yet, but the Kokkos generic implementation is working correctly. And so some future work on this is going to be to improve performance and perform integration with IFPAC2 and Trinos and others who might desire that. Okay, regarding the reverse Cuthill key, which is in the Kokkos graph, we have some fixes for invalid starting vertex where all nodes have equal degrees. So we had some heuristic to figure out which vertex to start with and had some fixes in some corner cases that were required. We now use a mean degree starting vertex for each connected component as well. So this is in case you had a disconnected component. So previously starting vertices for connected component other than the first were chosen arbitrarily. Okay. This one, now we're going to go in the update for TPL related topics. We're going to talk about rock sparse, sparse, and 1MKL. Most of the fixes and changes are related to SPMV and SPGEM, and a few bug fixes and quality of life improvement, I would say. So we had a multi-vector SPMV support with AMD. So if you had more than one matrix vector multiply, now instead of calling multiple times the kernel, we'll just do a single launch of the kernel that handles all your vectors at once. And we have improved the performance of SPMV with the rock sparse backend by using various algorithms that are provided by rock sparse depending on the sparsity pattern of your matrix. So for example, we have this SPMV merge pass, which typically handles better sparse matrices with imbalance in the number of non-zero per row. So if you have some few rows with lots of non-zeros, this might be a good option for you. And so we are exposing that now in the TPL layer as well. Regarding QSparse, yes, for SPGEM, we have some issues with QSparse 11.6.1. So we're now explicitly avoiding it by calling our own backend instead, if you're landing there. We also have fixed a configure issue where QSparse got enabled when Magma was enabled and QSparse was supposed to be disabled. So some of you might know, but Magma is another TPL that also has some QSparse and kuBLAS support internally. And so if you turn it on and you turn on QSparse, you can potentially get into trouble. So we are now detecting things that configure time a little bit better for you so that you don't end up in that situation. We are trying to improve the Kokkos profiling region for SPGEM by adding more precise labels. So this is partly for our own quality of life. When we do profiling and performance, it's nice to have precise label, but I think that's also useful for everyone who uses the library. Some fix in SPGEM, for CUDA later than 12.2, and then improve again some profiling regions. Similarly to what we've done for SPGM symbolic, we also have some profiling region labels for SPMV that are more precise. And the thing that I just talked about earlier, this native merge pass correspondence to Kusparse. So same as what we've done with Rocksparse. It's exposed in a more simple way now. Okay, and last TPL update regarding MKL. Don't use one MKL for unsupported SPMV modes NNC. So yes, when you have some transpose or complex or others, and I believe the modes are TNC, not necessarily NNC. When you have some issues with when you're using these and they're not supported by one MKL, we used to have some kind of bad results coming out of it. So we're now explicitly catching these things and calling our own implementation in Kokkos kernels to avoid these issues. And we also implemented a workaround for one MKL. GemV function, which is the dense matrix vector product this time, was mishandling the case where the beta factor is equal to 0, and you might have not a number in the output vector. The expected behavior is to zero out the output vector when you have beta equals 0, which means that nans are ignored by GemV. It was not the case in MKL, so we now perform a manual zeroing out of Y so that you don't see this behavior that is unexpected. Oh, sorry, there's a little more on one API. So we've done some work to make things compatible in Kokkos kernels and Trinos for the one API GPU support, especially regarding BLAST and LAPACK. And again, Kokkos Sparse SPMV algorithm native now accurately reports whether we're using the merge pass algorithm or the non-TPL equivalent. So again, more of a quality of life improvement. Okay, and final update, we've added some batch bandit solvers. These, added capabilities allow you to work with batch tri-diagonal matrices and bandit matrices. So we have a batch tri-diagonal matrix factorization, PPTRF, and we have a new batch triangular solve for bandit matrices, TBSV. So again, for this type of LAPACK functionalities, these are using potentially new matrices format, like tri-diagonal and bandit. So, they're very useful, but be careful when you use them and make sure you provide the appropriate matrix type as expected by these algorithms. And that's it this time for Kokkos kernels. Christian, maybe you want to take questions now?
Sure, we can take all the questions anybody wants to ask. Do I see hands? Hello?
There is one question in the chat asking how likely is it that 4.4.1 patch release will have the sequential host init view allocation property? Well, it's we would like to hear a bit more feedback that people wanted. So far, we only heard from you, Romain, and Victor. I don't know if there's are only users of Trinos, we could think of other way of giving you early access to it, but yeah, I guess we have one more vote. But anyway, I suppose we could gather more feedback on some issue on GitHub. What do you think, Christian?
Yeah, that sounds fine. There's one more vote for it, but my gut feeling is that we're gonna do it.
And to be clear, there is at the moment no other fixes, no things that were reported to us or that we discovered yet that we messed up in this release. So at the moment, that would be the only hypothetical things that would be in a patch release. Okay, well, if there is no further question, thank you, everybody. We'll stick around for another few minutes, but happy coding.
Bye-bye.